Hey everybody, this is Mike. So I've been using a Raspberry Pi as a home server for about 3 years. Recently the Raspberry Pi 4 was just had its BIOS updated to be able to boot via USB. I'd like to make some updates to my home server and I wanted to share them. I wanted to share what I was doing. This server is being used for 4 primary purposes. I have a network management server. I have it running a Unifi network controller. I use it for Pi-hole, which helps with ad blocking on mobile devices, or really your entire network if you'd like to set it up that way. And then I also have some MotionEye security cameras that I wanted to monitor and record video to. So I put this guide together. We're going to go through it today. We're going to make the Raspberry Pi boot from USB, install all the necessary software, command for command, and yeah, if you like this, maybe you can do this project at home on your network. What I've done in this guide is I've tried to cite some sources if I get some help from other people. So ETA Prime did an excellent video. When I was putting this guide together, the USB boot firmware was still in beta mode. The Raspberry Pi Foundation has just moved it to a stable release, as Leap covered in his video. And that's what we're going to go through today. We're going to install the stable version of the firmware. I have not updated that yet. Then we're going to delete this existing server. It was put together just as a proof of concept and a way to get this guide put together. And then we're going to go through this guide and get everything installed and working. Okay, let's go. Now, as you may have noticed, I'm working from a Raspberry Pi. This is not the Pi server. This is a separate Raspberry Pi that I have running. And I'm going to do all of the work while I'm SSH'd into the Raspberry Pi server. I could do this work on the server directly, but it's a little bit easier for me to show this guide and also show you what I'm doing on the server at the same time. Okay, so the first thing we want to do is update the firmware. Okay, so the first thing that you want to do is run these commands here. Sudo apt update updates all the repositories, and then we want to do a sudo apt full upgrade. This is going to upgrade all the software on the Pi. Next, sudo rpi update. Choose Y for yes. And then next we're going to update the file that controls what version of firmware is downloaded. So sudo nano etc default rpi eeprom update. Now this is set to critical, so we need to go ahead and change this to stable. Hit Ctrl X to exit, Y to save, and enter to overwrite the file. And then this command here is going to upload the new firmware to the Pi. If you're not familiar with using the terminal, I'm making heavy use of the tab key. Tab is an autocomplete key, and as I am not a perfect typer, it helps me a lot at typing what I mean to type. So sudo rpi eeprom update -d -f lib firmware Raspberry Pi bootloader stable Pi eeprom 0615.bin. That's what we want. Okay, so it looks like it applied. It says please reboot to apply the update, so let's do that now. Sudo reboot. We'll give it a few seconds to come back up, and then we'll check the version with this command here. Okay, so the Pi came back up. Let's check the firmware version. vc gen cmd bootloader _version. Okay, and we have the new firmware as indicated by the date here. And let's check one more thing. vc gen cmd bootloader _config. Okay, and this command I almost didn't need to run because the Pi did reboot successfully. But here we go. If you're running off an SD card, you can check that USB boot is enabled. And if you see this, that means that USB boot is enabled. Okay, so the next thing we're going to do is move this USB drive over to the Pi that I'm working on. This is a Raspberry Pi 8 gig, and image loaded up. So we're going to blow out all the work that I'd done. That's okay, and we're going to redo it so you guys can follow along too. Okay, now we're ready to move on to step 2, which is to create the bootable USB drive. So this could be an SSD, this could be a USB disk, or it could be a micro SD or anything like that in a USB reader. USB hard drive will work as well. So what we want to do is use the Raspberry Pi imager to flash the Raspberry Pi OS to the mass storage device. Then we're going to copy some firmware files to the boot partition of the drive. Now this was necessary when the firmware was in beta mode. I don't know if this step is still necessary, but we're going to do it anyway, and we'll learn to see if it works or not. Under the Accessories menu, I'm going to open the Raspberry Pi Imager software. This is something that I installed manually. I'm going to choose the OS. Now, this list is a bit crowded. It's because I'm using larger fonts on this Raspberry Pi. I'm going to choose Raspberry Pi OS Other, and then I'm going to choose Raspberry Pi OS Lite. This does not have a desktop environment or any other software installed, and this is what I prefer for use on a server. I don't need the desktop environment on the server, so that's the version I choose to use. Next, we're going to choose the SD card. It's a Crucial MX500 SSD, so there we go. Crucial Technologies MX500 SSD, so that's the SD card in this case that I want to flash. And the last thing that I'm going to do is click Write. Need to enter my Pi password on this Raspberry Pi to proceed. Now I may fast forward this part of the video, but I almost don't have to because it's working so quickly. This is a USB 3.0 SSD, so we do achieve speeds around 300 megabytes per second. I believe the size of the image that we're writing is around 400 megabytes total. For those of you who may be concerned about my temperature, this is temporary. I have a case for my Raspberry Pi 8GB in the mail. At the moment, it's running on top of the Raspberry Pi box in open air, no heat sink, no nothing. And honestly, I'm quite impressed with these temperatures. Okay, writing the software was successful, and it looks like it had already ejected the USB boot drive, so I can go ahead and click Continue. Now I'm just going to unplug and replug the boot drive because I need to also add the file called SSH so I can get back into it. Okay, so here we are in the boot partition. So, new file, SSH. Click OK, and what will happen is when this, when the Raspberry Pi is booting, it's going to look for this file, no extension, and if it's found, it's automatically going to enable the SSH server for me. So now we will eject the device, plug it back into the Raspberry Pi server, and turn it on. Now, one thing that you might need to do at home is spend a little bit extra time trying to figure out the IP address of the Raspberry Pi. What I had done before starting this video is I set a static IP address via DHCP. So every time this Pi server boots up, my DHCP server will always assign it the same address. So let's see if we can log in. Okay, we may need to give it a few more minutes to do its thing. On its first boot, it will resize the partition and reboot, and that does take a few extra seconds. Okay, so booting didn't work for me, and it's likely because I skipped this step. I ran the imager, but I did not download the updated firmware files. So let's go ahead and give that a try now. We'll open this link. And the updated files are located here. So I can just clone or download this entire folder. And while it's downloading, we'll get 2 Pi windows open. This will be the boot drive. And then this one will be the download. To extract this file, you can just right click and extract to here. So I'm going to sort this by details, and can I sort by kind? Yes, I can sort by extension. So the guide says that we need all .elf and .dat files. Okay, so here are the .dat files. We can do a copy and a paste, and we can overwrite these files. Okay, next we need to grab the .elf files. Copy and paste. Apply to all, overwrite. Last, we need to make sure the SSH file is still in here. And there it is. Okay, now we should be good to move over to Pi 4 server and boot it up. Okay, and we can see that the Pi was assigned an IP address and it's now communicating on the network. So let's see if we can SSH back into it. Okay. Now I'm getting host key failed because when it generated the new key for the secure connection for the SSH server, it's different than what I have already for the server. And that's because we blew out the operating system and created a new one. So of course it has a different key. So what I need to do is to check this file here, known hosts, and probably the easiest thing to do is just delete out that old key. So sudo nano home pi.ssh. Did you see my typo? Alright, we'll just clear this file out. Save it, and now we should be able to get back in. Here we go. It's asking if I want to trust the authenticity, and just say yes, and then it asks me for the password. Of course it's Raspberry because it's a brand new install. And let's continue on with our file. Before we start up the server, the next thing we want to do is prepare the Raspberry Pi operating system. There are a few things that we want to do in addition to software updates that will get the Raspberry Pi operating system ready to go. So the first thing is sudo apt update. Then we can do sudo apt upgrade. Okay, the next step is optional. I'm going to do it. It's just for fun basically, and it's going to check the speed of our SSD. This could be important because if the speeds are lower than expected, it could mean a bad USB 3 connection, and that could be something that you want to look into. So we need to install the agnostic software, so sudo apt install agnostics. Okay, next we're going to run step 2 to check the speed of the SSD. Okay, So the sequential write speed is about 300 megabytes per second. Target is 10,000, so that's awesome. We have about 12,000 input outputs per second for write and 17,000 for read. So this is definitely faster than USB 2 speeds, so that means we're running at USB 3, and the performance looks excellent compared to an SD card, so let's keep going. Next we're going to run raspbiconfig to set our language, time zone, and also change the hostname and password of the server. Okay, so the first thing I'm going to do is check the language. Okay, I'm in the US, so I'm going to pick ENUS UTF-8. Okay, next is the time zone. Okay. Next is to enable SSH. We can skip this step because it was already enabled by default with that file that we put in. So next we can change the host name and the password. Under network options is where we can change the host name. I'm going to call mine RPI4 server. We'll say finish, and we'll ask if we'll like to reboot, and then we can change the default password for the Raspberry Pi. This is an excellent idea, even if you intend to keep this Raspberry Pi on your internal network only. Just in case somebody were to get onto the network, they don't have the default password potentially to your home server. Okay, so we changed the password for the Raspberry Pi by typing passwd. We have a little message that pops up every time we log in right here. So we'll type passwd. It'll ask us for a new password for the current password, which is Raspberry. And then our new password, I'm going to use admin. Okay, how about some password? Some password. All right, there we go. Now our password is updated successfully. The next thing that I like to do is disable the Wi-Fi. What we'll do is sudo nano boot config.txt. So we'll go ahead and add that down here under the all section. Because I'm not always the best typer, Control C, right click and paste when working in the terminal, exit, yes to save changes, and when we reboot, the Wi-Fi will be disabled. Next step, we're going to install ZRAM. This is a tip from Nova Spirit. He has a YouTube channel. I recommend checking it out. Basically what this is going to do is set up a compressed area of RAM memory, and it's going to disable the swap file on the SSD or the USB drive. I recommend doing this on all Raspberry Pis, especially if you might get close to approaching the memory limit, just because I think it helps the Pi run a little bit faster, and it also reduces some of the wear on the micro SD card. Okay, so let's get to it. We're going to burn through these commands. Now, I have to right-click and paste in the terminal. You'll know that the control and different characters do different things. Control V often doesn't work. Copy the command, right-click paste, and hit enter. Okay, next we need to change the mode of this file so that it's executable. So copy, right-click paste. Then we need to sudo nano etc/rc.local, and we're going to add this line just before the exit, and what this is going to do is rc.local is a list of services that start up every time the Pi starts, and this is just going to launch our script for us. So copy, right click, paste, exit, yes, and reboot. Okay, good. So I use this command here to check my work, and as you can see, my ZRAM swap file did not work properly. And what I found is that I got auto-corrected. The user folder was auto-corrected to use, which of course is not a real location. So to fix that, we just do sudo nano etc rc.local. See right here it is used. That's not a real directory, so our ZRAM script did not launch. So we'll make that say user. Exit, save, enter to rewrite the file or overwrite the file, and we'll do sudo reboot. Okay, let's check our work again. So sudo cat prox swaps. Okay, there we go. We can see all of our ZRAM partitions. Now, this step here, I would say, is optional. I followed some of the advice in this article, though I made some of the values less extreme. I've been running it for a few days. It seems to work well, so I'm going to go ahead and set these values now. So sudo nano etc sysctl.conf. All right, at the bottom of this configuration file, we're going to add these lines of text. So copy, right click and paste. Everything looks good, so Control X, Y to save, enter to overwrite, and then we can set these values by typing the command sudo sysctl -- system. Okay, and there we go, those values are set. Okay, the next thing we're going to do is install Pi-hole. Now, of course, you can skip this step if you don't want to run Pi-hole on your server, but the order, I think, is slightly important, and the reason is because some of the services share the same port, and we'll have to work around modifying the ports that these services use so they run correctly. Okay, so the next thing we're going to do to get Pi-hole installed, super easy. We're going to paste this command here. Okay, next we're going to do sudo bash basic install.sh, and this bash script will go ahead and install the software. This is somewhat risky if you don't know who the publisher is of the script or of the software. I trust the team at the Pi-hole Corporation, so I'm just going to blindly trust what they're doing. I'd recommend you do the same, but of course do so at your own risk. Okay, so as we're running the script, it's going to walk us through some install screens. Pi-hole is a team of individuals like you and me. They donate their time to get the software running. So if you use it, if you enjoy it, I encourage you to donate to their team. Now, this warning says Pi-hole needs a static IP address. This is extremely important. I set up a static IP address in my DHCP server, so I am covered. If you don't know how to do that, or if you can't do that, maybe your routing doesn't have those settings, then you will need to set a static IP address on the Raspberry Pi. The next thing you'll need to do is pick your DNS server. You may want to pick one of these with ECS. ECS means that it supports the ENDS client subnet. Basically, what this technology is if there are servers distributed throughout the globe or throughout your country, ECS is going to give the IP address of the server closest to you, so that way you're not reaching out to a server all the way across the country. Of course, the longer the distance, the longer the latency, and even though it's in microseconds, that time does add up and it can slow down your experience. So choose whichever DNS server provider you prefer. If you're not sure what the difference is between them, then I'd recommend doing some research. Some are more privacy oriented than others. Also, some of these provide some level of content filtering, so if there's some areas of the internet that you want to filter for small children, some of these DNS providers can do that automatically without software. For the sake of this example, I'm going to choose OpenDNS. And then this screen here asks you which ad blocking packages you want to have installed. Generally, I choose all of them and click OK. This screen is going to ask you which protocol to block ads over. Again, I recommend both, even if you don't use IPv6 on your network. And then it's going to show you your static IP address information. If you don't know what this information is, you may want to write it down and set that IP address in your router. I'm going to choose no here because I have my router setting this IP address for me. Next, do you wish to install the web admin interface? I recommend doing so. Do you wish to install the web server LibreNMS? Yes, that's fine. Do you want to log queries? Probably. Select the privacy mode, show everything. I think that's fine. After everything is configured and you get to this screen, make sure that you write down the password. I have a note of my password here, so I'm going to update that. Okay, looks great. Password is case sensitive. Make sure that you get the case. And the installation is complete. Now, if you plan on installing LibreNMS, which is a network management server, then we'll need to move on to step C. I do plan on doing this, so I'll run through these steps. If you do not plan on running LibreNMS, then this step is probably irrelevant to your configuration. The reason we need to do this is because both Pi-hole and LibreNMS want to run on the same port, which is port 80. So we're going to modify Pi-hole to run on port 81. So we do sudo nano etc LibreTTPd LibreTTPd.config, and then we're going to look for port. Right here it is, server.port. We're going to change this to 81. If you get lost, the other thing that you can make use of is the where is command, so Control W, you can type port. You can see it moves my cursor right here to port. So Control X to exit, yes, save the changes. And then to apply the changes, we need to restart the service. So sudo system ctl restart LibreTTPd service. And next we can go here and check if Pi-hole is running. So let's see if these numbers change. Yep, and here we go. Only 19 queries. If you want to log in for more details, then we need the password that it gave us. Okay, and here we go. So Pi-hole's working, that's great. Okay, next, if you use Unifi in your household, you'll probably want to install the Unifi Controller. If you don't know what this is, look it up. Basically, it's a company called Ubiquiti. They make high quality network gear focused towards small and medium businesses. They make excellent wireless access points. I've had one in my house for several years and it's worked absolutely flawlessly, so I'd highly recommend it. So, first step, let's go ahead and run through these commands. First, we're going to install the OpenJDK JRE or Java Runtime Environment. The Unifi Controller does run on Java. Okay, next we're going to install RNG tools. And we're going to make a modification to the config file. Sudo nano etc default RNG tools. And we're going to uncomment this line here that says HWRNG. So just remove the hash that uncomments the line, Control X, yes, and overwrite. Next, we can restart that service. So sudo system ctl restart rng-tools service. Next, we're going to echo the path of where the Unifi packages are stored into the apt sources list. So copy this command, paste, done. Next, we're going to grab this repository. Okay, done. Next, we need to do sudo apt update, and we need to do this because we added the Unifi sources list. And then we're going to do sudo apt install Unifi. Now, if you're watching this video over several days, each new day I would recommend running sudo apt update, and that's because the packages are constantly changing. Okay, now that the Unifi software is installed, we can actually check if it's working. So type the IP address of your server, :8443. And here it is, we got a response. Your connection is not private. This is normal. Just click Advanced and proceed. Chrome or Chromium says it's unsafe because the SSH certificate is not signed. Next, what you would do is either set up your controller fresh for the first time, or if you have an existing controller like I do on my old Pi server, you can restore backup. Let's keep moving with the install. Next, we're going to install MotionEye. If you have any security cameras or Raspberry Pi cameras around your property, MotionEye is my preferred software to monitor those cameras. It's maintained by this guy, Syslog-ng, so if you enjoy the software or if you use it yourself, I'd recommend donating to the project. Okay, there's multiple pieces of software that need to be installed, and we can install each piece of software by separating it with a space, so let's get to it. We'll copy this command and get the required software installed. Okay, now that the dependencies are installed, we need to install the MotionEye software. Okay. Sudo dpackage I for install, pi buster, enter. Okay, next we have a few more packages to install, so we'll run this command. Next we can use this command to install MotionEye. And next we're going to copy and rename the MotionEye config file into the MotionEye directory. Next we're going to make another directory, and we're going to copy over the service. Then we're going to do a daemon reload and enable the MotionEye service. Okay, this is the last command, so MotionEye should be started, so we can check that here. We'll hit enter on this command, 8765. We should get to a login screen. Yep, and we did, so our install was successful. Now this next step is optional. You could have your MotionEye cameras save to a USB drive or save directly to the micro SD card. What I want to do for speed is have MotionEye save directly to my Pi server. So we're going to install Samba server, and I'm installing this specifically to support MotionEye. Now, if you wanted to run a network share, for example, if you had a large drive connected to your Raspberry Pi and you wanted your Raspberry Pi to be a Samba server for Windows networks, you could use the same method. It will work. Or you could use other packages, which I'd probably recommend, like Open Media Vault. Okay, so let's go ahead and start with step 7 to get the Samba server installed. So first we need to download the Samba software. If you have other Samba servers on your network, or if you're not sure what to do, then I recommend choosing no, and that is the default option. Now that the software is installed, we need to make a directory which will be our shared directory. So if you have a larger drive, like a USB drive that you want to share, make this directory on the external media. If you do have an external USB drive, one that you're not booting from, I recommend mounting it in a way that it always mounts in the same way, with the same name to the same location. That is not covered here, but there are ways to do that, so make sure to look into doing that. I'm going to recreate this directory because we're using it specifically for MotionEye. I just renamed the directory. So there we go. Now we have a folder in our home directory called MotionEye. Next we need to modify the config file. So sudo nano etc samba smb.conf. We can scroll down to the end, and what we're going to do is create a new section of this file whatever name is in this brackets is what the share is going to be called. So regardless of the folder name that you created, this is what that folder is going to appear on the network. So I created a MotionEye folder. I also want that folder to appear as MotionEye on the network. And make sure this path is correct. So if you called your folder something different, or if you put it in a different location, then make sure that you modify this path to reflect those changes. Everything else can be set as is. This controls the permissions, and public equals no. If you do want guests to access the media, then change public to yes. Next, we need to set up a user and password. So sudo smb passwd a MotionEye. It's asking for a new password. I'm going to use this password called admin. Okay, and the password failed because we don't have a user for MotionEye, so we'll follow these steps down here to create that user. So sudo add user MotionEye. Okay, new password, admin, full name, MotionEye, room number, none. Is the information correct? Yes. And we can change the owner of the folder. So sudo, chown for change owner. And then it says user folder. So the user we want is MotionEye, and the folder we want is MotionEye. Not confusing at all, right? So now let's rerun our password, sudo smb passwd a MotionEye, and we'll put the new password in. Okay, and this time we were successful. Now we need to restart the SMB service so that our changes are applied. So sudo systemctl restart SMBD. Okay, now I'm not going to run through how to add cameras to the MotionEye. There are plenty of videos on the internet that do that. If you wanted to do like me and use your network share, then you would type the IP address of your network server. The SMB protocol 2.1 works well for me. I have two cameras, a driveway camera and a garden camera. Then the username and password that we just programmed. So I used MotionEye and the password of admin. The root directory could probably be /. Next, we're going to install an FTP server. This is going to be used for any network device that might want to upload an FTP copy of log files. Okay, so next what we're going to do is cd squiggly line tilde, is that what it's called? Basically that's the shortcut for our home directory, and we're going to install Pure-FTPd. So let's get into it. Sudo apt install Pure-FTPd. Now, similar to Samba, we're going to need to create a group and an FTP user. For the sake of the video and these examples, I'm going to use the FTP group and the FTP user. Sudo group add FTP group. And then sudo user add FTP user, G for group, so FTP group, or whatever group name you choose, S, sbin, no login, and D dev null. Okay, and this is going to make it so that FTP user does not have the ability to log in to the Linux operating system. Next, we're going to make a directory for FTP, so sudo make dir pftp. And you could name this directory whatever you wanted. Next, we need to change the owner, so sudo chown capital R for recursive, and we're going to use FTP user and the FTP group, or whatever you called them. And then we're going to type the folder name, which was FTP. Okay, next we're going to set the password. So sudo pure-pw user add FTP logs. So that's my password. to user, FTP user, group is FTP group, and the directory, which is located home, pi, FTP, and the M flag. Now it's asking for a password, so I'm going to set the password as FTP logs. Next we need to apply our changes, so sudo Pure-PW make db, sudo symbolic link to etc Pure-FTPd conf pure-db, etc Pure-FTPd auth 60 pure-db. And finally, restart the service to apply the changes. Sudo service Pure-FTPd restart. And we're done. Your FTP server should be up and running. Okay, let's try to connect to our newly created FTP server. So we type our IP address. And let's log in as our user, which was FTP logs. And our password was also FTP logs, going for only the highest security here on the server. Okay, it looks like we're mounted, so let's try to create a file. We'll call this file testfile.txt. Okay, there it is, 0 bytes. We go over to our terminal and we cd into the FTP folder. Here we can see our test file. I would consider this a success. Okay, next, part 9, we're going to install LibreNMS. This is quite an involved install, so make sure you have enough time to do this. Let's go ahead and get started. First, what I'm going to do is change back to my home directory, and then what we need to do is install a bunch of packages. Now, if you're following along with the LibreNMS documentation, there seems to be a small typo right now. All instances of PHP software need to be updated to 7.3. The first time I went through, I did not make this update, and I hit some weird errors. It took a little while to uninstall all the old software and reinstall all the correct software. So I probably recommend doing a copy and paste of this command just to make sure you have the right version of the software. This video is created in June of 2020, so if you're watching much later than that, this software might be updated to a new version, so just be mindful of that. So first we'll install software properties common. Then we're going to run sudo apt update. Now because we're doing this all at the same time, we can probably skip this step, but we're going to run it to be safe. And then this is quite a long command, so we're going to copy this into our terminal. Now the first time I went through this file, I didn't change the port of Pi-hole, so I did run into an error. If you chose not to change the port of Pi-hole, you might run into the same error. No problem, just go back into the config file and make the update. Okay, now that the software is installed, we're going to add a LibreNMS user. So we'll copy these commands. So we're adding the user and the group. Next, we're going to download LibreNMS. So we're going to cd into the opt folder for optional software. And we're going to run this command git clone LibreNMS. Next, we need to set the permissions. So we're going to change the owner of the software to be LibreNMS. And we're going to change the mode of the folder. Then we're going to set access control. Okay. Next, we're going to install PHP dependencies. So sudo su LibreNMS. We're going to run this script. Now that the script is run, we can exit. Okay, next we're going to configure MySQL. So we'll use these commands. This is going to set the password for MySQL. So I'm going to use the password admin for this example. And then we can issue all of these commands. So I'll highlight the block, paste it in. Everything queried okay, so we can type exit. Next, we need to make a change to the configuration file. So we're looking for the MySQLD section, which is right here near the top. And we're going to add a couple of lines in here. So I'm just going to add it in here right under the section. We're going to add these 2 lines. So copy, right-click, paste, and then we can Control X to exit. Yes, that we want to save, enter to overwrite, and we'll restart MySQL. So sudo systemctl restart MySQL. Okay, next we're going to configure the time zone. If you're not sure which time zone you're in, this link here will provide some examples. And I'm going to use Control W and search for time zone. Okay, right here it is. In fact, let's open this link and have a look. Here's America, New York, and as you can see, I made a typo. So there we go, America, New York. Let's exit and save and configure the next file. Again, I'm going to Control W for time zone. Right here it is. So America, New York. We need to uncomment this line. So remove the semicolon. Next, we're going to enable and disable some mods. I could probably highlight and paste this entire block, but let's just go one at a time. Okay. Next, we're going to configure Apache. So we'll copy this line to open up the LibreNMS configuration file. Or, well, create the configuration file. We'll copy in these lines. This is about all we really need. If you wanted to change the port that LibreNMS runs off of rather than Pi-hole, this is where you could do it. Now, only execute this step if this is the only Apache 2 site. It is, because Pi-hole is running off of light TTPd. If your Raspberry Pi server has other sites running on it, then do not execute these steps. This basically just disables the default website. Okay, and finally it keeps warning us to restart Apache 2. So here we go. Done. Next we're going to configure SNMP. So let's move into this configuration file. We're going to copy the example, and then we're going to use nano to edit. And where it says random string goes here, this would be your community name. Hopefully you know a little bit about how SNMP is working. Most SNMP controllers use the community name public, so that's what I'm going to put in here. So we'll exit saving changes, and we need to grab this distro, update the folder mode, and restart the SNMP service. And we're going to set up a cron job, and we're also going to set up log rotation. Okay, next we should be ready to log into the interface. I am not working on the local host, so I'll need to type the IP address, and then we'll need to enter our database password. I think I forgot to mention earlier, this password was set in the DB configuration file earlier in the instructions. I'll make a highlight of that so you can set a more secure password when you do your server setup. Okay, so we still have some steps to do for the install. We'll go to the next stage. The password is mentioned here, so the password is password. Next, we'll add a user. You can call this whatever you want. I'm just going to use admin and admin, and for the email, me@local should be fine. And then we'll generate the config file and finish the install. Next, what we'll need to do is validate the config and fix issues. So we'll click this line here. I'll log in with admin or whatever login you just created. And this first login should take a few extra seconds because it's going to run the validation file. Down here are a few things that we need to fix. And what's nice is we can just copy these lines into the terminal. Okay. Now that that's done, if you also want to set up a Syslog server, which I'd highly recommend, that's going to happen here in step number 10. Otherwise, we can go home to the dashboard, and LibreNMS is up and running. In fact, let's just go ahead and install let's go ahead and add the localhost so we can keep an eye on its statistics. Okay, there we go, localhost is added. So we should have some information for this device when we come back later. Here are two pieces of documentation, a YouTube video by CWNE, I believe, 88. He did a great job installing the server, and also there's some information on the LibreNMS documentation about how to get Syslog to work with LibreNMS. So the first thing we're going to do is install the Syslog server software. And then we're going to modify the config file. Now, LibreNMS recommends that we replace the config file with this information, so I'm going to go ahead and do that. But as you can see, there's a lot of information already in here, so we're going to create a new blank config file. So first we're going to use the move command. We're going to move it from that name to etc syslog-ng syslog-ng.conf.org for original. And then we're going to touch a new file, etc syslog-ng, get rid of that .org, oops, got sudo. And that basically created a blank configuration file with the same name. So now we can sudo nano etc syslog-ng syslog-ng.conf. Now our configuration file is blank. So copy all this text and paste. There we go. Now we can exit and save our changes, and then run sudo system ctl restart syslog-ng, and that will apply our changes and load our new config file. Last, we need to edit one more config file for PHP, and we need to search for this line and double check that it is set correctly. So I'm going to Control W for where is, and I'm going to type enable syslog. Okay, and it says not found, so that's fine. What I can do is copy this line, arrow down here, and paste, and now we have it. And that's it. There are some LibreNMS optimizations that LibreNMS recommends that you run. It seemed to break the ability for LibreNMS to pull devices. Okay, so it's been about 20 minutes now, and LibreNMS has been able to collect some data on my device, so I know that it's working. So that's it. That concludes this video. Go ahead and give this a try. If you need a server at home, or if you're using a higher power device, consider giving a Raspberry Pi a try. I've been running a Pi 3 for about 3 years now. It's been perfectly stable. Now that the Raspberry Pis have more RAM, I'm going to step up the game a little bit. LibreNMS does use a considerable amount of system resources, but we're not touching any of our swap space. We may in the future, depending on what happens, but we should have plenty of space. We have another 3.8 gigs of swap space to use, which is just compressed memory. It's not swapping to the hard drive or anything like that. So let me know what you think. Let me know where I could improve. If there are things that I did wrong, put it in the comments. If there are things that are insecure, let me know. Let's all learn from it. Thanks, guys.